this video lecture, we are going to see an activity to show how acids and bases react together. That is, acid plus base will give me what? Okay, this reaction is very important because it is used in our day-to-day life. Now I'll show you what will happen when acid and base react together. I'll show step by step. And for that purpose, for acid we are taking dilute HCl and for base we are taking dilute sodium hydroxide for this experiment. Okay, HCl and sodium hydroxide are the commonly used acids and bases. So this acid and this base we are using for this particular experiment. And my main activity is I have to find out how acids and bases react with each other. So what is the aim of my experiment? To perform an activity to test whether acids and bases react together to give salt and water. That is, whenever acids and bases react together, we get salt and water on the product side. That is the aim of my experiment. I said, right, what will happen when acid and bases react together? When acids and bases react together, they form salt and water. Let us see how. So the materials required for this activity are a test tube. We need 2 ml of dilute NaOH solution, and we know dilute NaOH solution is the base. So here for base we are taking NaOH solution as I said earlier, and we require 2 ml of dilute HCl solution that we are taking as acid, and we need phenolphthalein indicator. So why do we need phenolphthalein indicator? An acid base indicator, or simply an indicator, is a substance which is used to test whether a given substance is acid or base. That is, with the help of indicator we can find out whether any substance is acid or base. Here the type of indicator we are using is phenolphthalein. So whenever there is a change in color, we will know whether it is an acid or base. Now what is the procedure? We are going to take about 2 ml of dilute NaOH in a test tube, and then we are going to add few drops of phenolphthalein indicator to it. And on adding phenolphthalein indicator to our sodium hydroxide solution, we can observe that the color of the solution turns pink. We are taking a test tube. In that test tube we are pouring sodium hydroxide solution, which is a base. We know that actually sodium hydroxide solution is not pink in color. Okay, and when we put 2 to 3 drops of phenolphthalein indicator in this sodium hydroxide solution, that solution will turn to pink color. So this color will get after we put phenolphthalein indicator. So we observe that NaOH solution is becoming pink when we put this phenolphthalein indicator. That is the first step we are doing. So why will that turn pink? Is as NaOH is a base, the solution turns pink. Okay, earlier we did not know that NaOH is a base or acid. Let us assume that we don't know that NaOH is acid or base. So we want to find out whether NaOH is acid or base. That is, sodium hydroxide is base or not. We have to find out. For that I am pouring some drops of phenolphthalein indicator to it, as you can see here, and then I am finding that the color changes to pink. Okay, so as NaOH is base, the solution turns pink. That I have observed. Now next step what I am doing, I am adding this few drops of dilute HCl to this test tube. Already the solution is pink in color. To that pink solution, which is having already sodium hydroxide in it, to that I am pouring some drops, few drops of dilute HCl. So when I pour few drops of dilute HCl in this test tube, which is already having NaOH solution and which was pink, we observe that pink color disappears and the solution immediately becomes colorless. Colorless means it will become like water. Okay, water also does not have color, right? So that pink color is immediately changing to colorless when we put dilute HCl in this test tube. Okay, so why is this changing to colorless? Is that for the phenolphthalein, as you can see on the screen, phenolphthalein indicator, as I said, indicator is used to know whether it is an acid or base. How do we know whether it is an acid or base? By the change in color. So phenolphthalein always turns pink in case of basic solution, and phenolphthalein always turns to colorless in acidic solution. So here we observe that when we add dilute HCl to the test tube, it is changing to colorless. That indicates that the substance is acid. Now base is being turned to acid. That is what we got to know by our observation. See, as HCl is an acid, okay, and already phenolphthalein indicator was present in the test tube, right? So that pink color is disappearing from the solution. Now next what we are doing is, again we add sodium hydroxide solution drop by drop to this test tube. So this test tube now has HCl solution, as well as already it was having basic solution and already it was having phenolphthalein indicator. Okay, and now let us assume that this is colorless in nature. Just now we got right. This is colorless. Okay. Now, when we add this NaOH solution to this test tube, we observe that that colorless solution again turns to pink. That is, pink color reappears in the test tube. So, why is the pink color reappearing in the test tube? Because we have added sodium hydroxide solution. We know that whenever sodium hydroxide solution is mixed with phenolphthalein, it will change to pink color because phenolphthalein turns pink in a basic solution. So again, this third time, this test tube is becoming pink in color. Okay, so did you understand? First, to the test tube, we are adding phenolphthalein indicator, and that sodium hydroxide is turning to pink. That indicates that it is a base. Then again, we are adding dilute HCl to the test tube, and we observe that the pink color disappears and it is becoming colorless, and to that colorless solution again we add sodium hydroxide solution, and that solution turns pink in color. So here we observe that in the above activity the pink color disappears on adding HCl as sodium hydroxide reacts completely with HCl. Okay, that is here we are observing that the pink color is disappearing. In the second case, the pink color is disappearing. So why is the pink color disappearing? Because already sodium hydroxide was there. Now when we add dilute HCl, we know dilute HCl is strong. So that dilute HCl will remove the sodium hydroxide solution. That is, it will neutralize the sodium hydroxide solution. That is, this is no longer a base. In the first instance, in the test tube we are having a base. Now when we add dilute HCl to the sodium hydroxide, it is no longer a base, but it is turning acid. Okay, that is the effect of base is nullified by an acid. Okay, it is no longer an acid. Now, we will also observe that so I'll tell the observations again. As NaOH is a base, the solution turns pink, right? Here, as the NaOH is base, the solution turns pink. Okay. Now again, what did we do? We added dilute HCl. So when we add dilute HCl, the pink color disappears from the solution. Now we are adding 2 or 3 drops of NaOH to the above mixture. So we can observe that NaOH is base, pink color reappears when adding NaOH. Okay. So just now pink color reappears. Why pink color reappears? Pink color reappears on adding sodium hydroxide because the solution becomes base again. Okay. That is, when we add sodium hydroxide solution third time. When we add sodium hydroxide solution third time to that acid, what is happening? The sodium hydroxide solution is mixing with phenolphthalein indicator, and that is becoming basic again, because pink color means it is a base. So what is the result we got from this experiment? The reaction of an acid with a base in the above activity can be written as NaOH, which is aqueous, plus HCl, which is aqueous, gives rise to NaCl, which is aqueous, plus H2O, that is liquid. That is, whenever sodium hydroxide is being added to hydrochloric acid, it is forming salt. How will it form salt? Will be displaced here. This will be displaced here. So sodium forms with chlorine and forms sodium chloride. Here we have one molecule of hydrogen, and here also we have one molecule of hydrogen. 1 plus 1 is 2. So 2 molecules of hydrogen and 1 oxygen is left. So water. So base plus acid gives salt plus water. So this is the conclusion which we get from this activity. That is, whenever acid reacts with base, we get salt plus water. Be it any base and any acid. Here the acid which we have taken is HCl, and here the base we have taken is NaOH. We observe that it is forming NaCl, which is salt, and water. If someone has acidity problem in the digestive system, okay, and he goes to a doctor and tells him that I have digestivity problem, please give me some tablet. The doctor will give him a tablet which has antacid in it. Why the doctor gives him a tablet which has antacid in it means antacid is a base. Okay, so always remember, acid is a bit dangerous and base is good. That is, base will nullify the effect of acid. That is the reason why we are when one eats an antacid, his digestion problem of the acidity will be resolved. Okay, so this is a practical application of how acid is reacting with base. That is how the base is nullifying the acid effect, and the person will get normal. The person will no longer have illness. The person will no longer have acidity problem when he consumes that antacid. That is, whenever the antacid is consumed in the digestive system, it will form salt and water. Okay, we can see that in the practical application. So thank you very much for watching. Hope you have understood this experiment. Please share the video with your friends and subscribe if you are new.